You know, one of the most important ideas in life, actually, is the idea that when we have something complicated, we try to break it down into smaller pieces to get better understanding. And that applies in math as well. We have a number and we break it down into smaller pieces so we can get a better idea of what makes up that number. What we'll be doing now, it's called prime factorization. We take a number, we find out its factors, and ultimately down to the smallest factors that can no longer be divisible by any other whole numbers. So let's take a look at an example of factoring the number 72. One common way is with a tree. So numbers do grow on trees. Prime factorization with a factor tree looks like this. We take the number 72 and we think of two numbers we can multiply together to get 72. How about 9 and 8? Well, that's good. Now we look at 9. Is 9 a prime number? No, because we can divide it by another whole number. 9 can be divided by 3, and it is made up of 3 times 3. Well, it turns out 3 is a prime factor, so we're going to stop here on this branch of the tree and then continue with this other one. 8 is the product of 2 and 4, and once again we see one of these numbers is prime. 2 is a prime number, and we're almost done because now we see 4 is actually 2 times 2, and we're done finding our prime factors. So it turns out that 72 can be broken down into 3 times 3 times 2 times 2 times 2. So let's just write that out here. 72 equals 2 times 2 times 2. I got the 3 2's here, and then times 3 times 3. And it's a nice way to write this by using exponents. So this is actually 2 to the third, and this is 3 squared. Another way to do this is with what people call a ladder. A ladder, well, we start with a number 72 in this case, and we'll try a ladder for prime factorization. And we build this ladder one rung at a time. Here's the first rung. Just consider a number that divides into 72. Well, how about 2? That works. 72 divided by 2 is 36. We now make another rung on the ladder. Do the same thing. What goes into 36? Let's do 2 again. 2 times what is 36? 18. Well, we're rolling with these 2's. Let's do another one. 2 goes into 18 9 times. And for the next rung, what goes into 9? 3 goes into 9. Goes in 3 times. And now we're down to this last 3. 3 is just 3 times 1. This 1 is just our signal that we have finished finding the prime factors. So I've got a 2, a 2, a 2, a 3, and a 3. And this gives us the same thing we had from the factor tree. 72 equals 2 times 2 times 2, which is 2 to the third, and 3 times 3, which is 3 squared. So factor trees, factor ladders, either one, both very useful tools to find prime factors. Now let's take a look at greatest common factor. So greatest common factor, we're considering what is the biggest factor of 2 or more numbers. Let's start with, how about 36 and 54? We want to know what's the biggest number we can divide evenly into both 36 and 54. So one way to do this is to just list all of the factors of each of the numbers. 36, well, 1, 2 goes into 36, 3 goes into 36. Does 4 go into 36? Yes, it does. 5 doesn't, then 6 does. 7, 8, 9, 10, 11, 12 goes into 36, and so does 18, and then that brings us to 36 itself. So this is a list of all of the whole number factors of 36. Let's do the same thing with 54. We know 1 goes in there, we know 2 goes in there, 3 does, If you use divisibility rules, you'll see 3 goes into here. Does 4 go into 54? No, 4, 5, 6 does, because 6 times 9, and in fact 9 is going to be the next one in our list. And then we jump to 18. 54 is 18 times 3, and then 27 and 54. This is a list of all of the factors of 54. And now we start looking for the ones they have in common. We're not really concerned about one. They both have a 2. They both have a 3. Ooh, they both have a 6. And look at this, 18. So greatest common factor means we're looking for the biggest one. The biggest one here is 18. So the greatest common factor of 36 and 54 is 18. We have another way to do this. We spent a little while looking at prime factorization, and prime factorization is a great tool that we can use to find the greatest common factor of numbers. Let's see how that works. We've already found a greatest common factor by listing all of the factors of a number, but that can be kind of time-consuming, and also with larger numbers, it can be really difficult to find them. So let's consider 45 and 75. We'll use the prime factorization to find the greatest common factor of these two numbers. I could do a factor tree and find the prime factors that way, but these numbers are probably simple enough to do this mentally. 45 we know is 9 times 5. 9 is 3 times 3. So this is 3, 45 equals 3 times 3 times 5. Wonderful. 75 is 3 times 25, and 25 is 5 times 5. So 75 is 3 times 5 times 5. Now that we have the prime factorization of the two numbers, we're going to look for the prime factors they have in common. Well, we see they each have a 3, and they each have a 5. But this other 3 and this other 5, they're not the same in both numbers, so the only prime factors that are in common are a single 3 and a single 5. We now take these two numbers, 3 times 5, and that is 15. It turns out that 15 is the greatest common factor of 45 and 75. This even works when you have more than two numbers. We can try this with 24, 40, and 64. 24 is 3 times 8. 8 is 2 times 2 times 2. So 24 is 2 times 2 times 2 times 3. 2, 4, 8, 24. 40 we know is 4 times 10. 4 is 2 times 2. 10 is 2 times 5. So the 4, 2 times 2 is the 4. 10 is the 2 times 5. If you want to double check, just multiply the prime factors and make sure you get back to this number. 2 times 2 is 4, times 2 is 8, times 5 is 40. 64. 64 is 2, 4, 8, 16, 32, 64. It's 2 to the 6th. 2, 4, 8, 16, 32, 64. So this is 2, 4, 8, 16, 32, 64. We're going to do the same technique we did over here with 45 and 75. We're looking for the prime factors that we see in all three of these numbers. So they all have a 2. They all have another 2. They all have a third 2. And now we have run out of numbers that we see in all three of them. So we're going to multiply those 3 prime factors, 2 times 2 times 2, and that gives us 8. So the greatest common factor of 24, 40, and 64 is 8.